I'll try to stay in a 30 minutes mark. So let's get started. So, of course, I'm an Android engineer. I've been working on Kotlin for quite a few years now, and I've always been fascinated by the possibilities the possibility of using Kotlin in other environments rather than Android. Of course, I can run it on desktop, I can run it on backend, but something that really I wanted to try was to run it on iOS devices. So, this is not a guide on how to get started on Android multi-platform. There are already a lot of guides on the web, especially those from the friends at TouchLab and people from JetBrains that are very, very good. But this is an opinionated version of the trip that I had to take in order to get started with these new functionalities. Okay, let's start right away then. But before we dive into our talk, there are a few premises that we want to make. And I want to make sure that we are all on the same page. So, first one is that I am an Android engineer. I have no interest in being a cross-platform engineer. I want to be an Android and occasionally be able to run my code somewhere else. But that's occasionally. I'm not gonna be a cross-platform developer for the time being. And of course, I want to use my knowledge as much as I can. I learned a lot of things on Android and I want to use them as much as possible. So of course, this leaves us to using Kotlin. So, we already said that I love Kotlin, and even if there are other languages that probably are more mature for the use case that we are exposing, like for instance, Flutter and Dart, I don't really feel like it. I mean, I love the idea, I love the implementation of the UI, which is amazing, but I don't really like the idea of using Dart that much. On the other hand, if we use Kotlin, for the time being, we need to interact with Swift, at least a little bit. Okay, so of course we're gonna use Kotlin for the vast majority of the code, but since we don't want to use Dart, well, we only have Swift as a bridge to get on iOS. So the sample that we're gonna build is a simple app, a really simple app that only makes a network call, gets back the result, and shows a picture based on some informations that we get from a backend. My example in this case is an app that will show us the color of the lights that are currently used on the Empire State Building. From a few years, actually a couple of decades, I think, the Empire State Building can be enlightened in different colors, every color matching a specific meaning. For instance, on Columbus Day, it is highlighted, lighted up with green, white, and red colors. So, since I'm a fan of this building, I decided that I want to be updated every time, well, to know exactly what is the light I can see if I ever get to cross by that building again. A couple of things to mention is that I've used Android Studio Canary because I used Compose to write my UI so that I could basically convert the same UI into Swift UI later on iOS, but neither of these two frameworks will be showed in this talk. This talk is more about the underlying code rather than the UI. Another mention that it's interesting for this specific use case that Empire State Building website doesn't provide REST API. So I had to build a very small service that would scrape the light out of the HTML and serve them as a REST endpoint. Okay, so let's dive into the code. I was joking. First, a little bit of architecture. So, why is this important? Well, this is important because we all have our own way of architecturing stuff on our code. Might it be MVP, MVI, MVVM, MVC, whatever, clean architecture, whatever. We still need separations of layers. That's the important thing, in my opinion. So, how would we do normally on Android? Well, first of all, we would always need an activity or a fragment or anything that actually can be shown. So view, fragment, or activity, well, no, not much more. Another case. Then we want something like a view model that can survive the activity rotation so that we can use that as a bridge to get our data from the repository. Of course, both of these are linked to Android and the view model, even if the version that we might be using is the one without context, is still provided by Jetpack. And this is something that we need to take into account. Then we have the repository. We'll dive deep into the repository in a second. And the repository will reach out for the network, save our data on database, on a cache, whatever we want, and then return it to us. Okay, so this is the overall architecture that we might use in these kind of scenarios. Very simple. I think it's quite effective, especially when you only have to make one network call. Probably an overkill with one network call, but we'll see that this is actually needed in our specific case. So let's see the repository. Well, it might be weird to see that I put here an Android, but there's a reason for that, because normally everyone that is on Android for the past years, for instance, is probably used to make network requests, especially REST requests, by using retrofit. I mean, that's basically standard for network request. And apart from few people, I believe, that use other serialization and deserialization libraries, well, JSON and Moshi are by far the most used. But there is a reason, there is a problem with those. That is that basically we cannot use them on Kotlin Multiplatform because they're all based on Java library, Java, and well, we don't have a way to make them run on Kotlin Multiplatform as of today. Probably there will be soon, but as of today, we have to rely on other technologies. For instance, Ktor and Kotlin X serialization. Those are two very good libraries that work basically everywhere, including Kotlin Multiplatform, of course. And we will see that they're not that much different from the other libraries that we just mentioned. So now, once we swapped our libraries, our repository is truly platform independent, and our Android part is basically everything that goes from the view model all the way to the UI. So we can divide our project in two modules. The first one is the native module, the Android module, that includes the activities, the view model, basically everything that comes from either Android, Jetpack, or Android-specific libraries that we might be using. The other module is the shared one, and here is where we're going to put all our shared code. Beware, you need specific libraries in order for this to work as expected. So we're going to focus on this shared module because this is where the interesting part is actually happening. Of course, we want to write this in Kotlin. I can never stress this enough. So let's get started. Of course, we're gonna start from an Android point of view. Of course, we are Android developers, we know Android way better, and we want to interact with Xcode as little as possible, especially because I definitely prefer Android Studio and I'm more familiar with it. And again, this is something that an Android engineer might be doing, unless you prefer Xcode, but that's on you. So, first, we need to set up our project. When I started studying for this talk, it was, well, for Droidcon Italy, when it was firstly scheduled to be in person in April. And well, back then, the project setup was quite complicated. Luckily, the folks at Touch Lab created a project, a GitHub project that you could clone and use as to start your own project, so that you didn't have to include everything and restart everything on your own. While this is a valuable resource, this is not strictly needed as it was a few months ago. And that's because, well, there is a plugin for that now. The plugin is called Kotlin Multiplatform-ready, and it's developed by JetBrains. And basically, everything we need to do is simply get in this plugin, install it, and restart our IDE. And that's basically done. Then we can create a new project, and you need to scroll all the way to the last element in the templates. You will see a KMM application. This is what we're gonna need. Once we complete the whole flow, we'll be presented with the final screen, which is where we're gonna configure our modules. Of course, we can define a name for both our Android and iOS apps modules, and then for a shared module. Here's also a flag for adding tests to shared modules. In this example, I didn't write any because it was a simple network request. But if you were to implement a real repository with different use cases and probably caching, well, I suggest that you really flag that checkbox. At least you have everything set up also for testing, which is always good. Okay. Once we created the project, it's time to create some code. But, well, we should not rush that much, because we need Gradle to complete all its tasks before we can write anything shared. Because expect and actual two pillars of Kotlin native or Kotlin multi-platform can work effectively only after Gradle finished creating all the files, synchronizing them, and be aware of everything. Okay, now Gradle finished, and we can see, we can start seeing some code. This goes again in the shared module. And these are the models that we're gonna use to represent our lights. So let's start from the first one. Well, this model describes a particular light. So we have a URL for the image, the color, which unfortunately is not an X color, but it's rather a description of the color, like sky blue or green, white, and red, or purple and gold, but it's a human readable description. Then we have a field which is the reason, because for every light there is always a reason for that to be with that colors. And of course, the last one is the date. So the date is a string in this specific case for brevity, because I didn't want to start and parse dates. There are libraries that do that, even on Kotlin multi-platform. There is the new one from JetBrains, which looks really nice, but it was a detail. So just imagine this is a normal date with Yoda time or Android 310, whatever you prefer. The only reason is time constraints. The second model is, well, the response that we get back from the server, because the server will reply to us with the colors that we can see today, which is the today color, the picture for the today color, and a list of daylights, which are the next one in the future. One thing that is worth mentioning is that both these classes are marked with the @serializable annotation. This is because we want the Kotlin X serialization library to be able to serialize and deserialize them automatically. One thing to notice is that we need to mark them both, because every class that is marked with @serializable needs for all these children to be marked as well. Otherwise, it doesn't know how to represent the parent. So these are our models, pretty close to what we usually will see. Then let's go to the real repository. This is where I would normally use retrofit. Well, in this case, we cannot use retrofit. We had to use Ktor. So the first thing that we want to do is creating an HTTP client and install the JSON feature. Oops, sorry. The JSON feature actually will need a JSON object to be built, and we need to use this JSON object to create the serializer for the Kotlin X library and attach it to the HTTP client. Then, a very important thing is that we're gonna create a suspending function that will take the HTTP client and invoke the get method, which is the method, the HTTP method that we want to run against our backend, with an endpoint. And that will return our lights object. So, is it different from retrofit in this case? Yes, we don't need an interface defining all our methods, but we'll need to create an HTTP client that will then use to invoke the specific HTTP method to a given URL. Of course, this is a very basic example, but you can do the same with post, put, and delete, and whatever you want. And both Ktor and Kotlin serialization actually works pretty nice together. Okay, now let's switch to the Android part, because, well, this is where we would normally use our repository in every model. So for this example, I didn't use any dependency injection because, well, it was just one dependency. Normally, if you were to use Kotlin Multiplatform, you will need to use a framework like Coin, which is really simple to use on Android and would help you if you have multiple dependencies. In this case, we only had one, so we didn't really need it. So this is a normal view model that we can see on Android, and it's based on a live data, actually a mutable live data, and being exposed as a live data. You can do the same with flows, with observables, whatever you feel comfortable with. What I did in this specific example is using a pattern called loading complete error, so that it could, well, it's always easy to restart the flow every time we need it. So the first thing we do is emitting a loading error, a loading state, and then we try our coroutine, and in case we launch the complete or error. So the first thing we do is, again, emitting the loading. Then we use the view model scope and we launch our coroutine, because on Android, it doesn't change anything. We will run the code exactly as we are used with coroutines. We get the result. If everything goes as we expect, well, we invoke the success event from the loading complete error. Otherwise, we invoke the error. So we have three states: loading, complete, and error. I used the post value, but here, since we are on main thread already, we don't really need it. A simple value would have done the trick. Okay. So Of course, nothing will ever go smoothly, so expect some strange errors. Uh, for instance, this one. Um, as scary as it might be, well, just says that Android Studio cannot recognize the modules. So the only things that we can do in this case is close project and IDE. It's important that Android Studio is closed. We delete the .idea directory in our project, and we delete all the .iml file. And then we simply fire up Android Studio again and report the project. Well, another scary error that I found was this one. How this happened? Well, basically, I was on Canary 14, and then I updated to Canary 16. Well, that didn't really go as planned, and I saw this error. What was this error about? Well, it turns out that this error was actually due to Gradle. I was using a milestone version of Gradle, and updating it to 6.7 or 6.8 actually fixed it. Okay, now let's switch to iOS. So for this sample, I took inspiration from the Code Lab from the amazing folks at JetBrains, which is very, very nice, very easy to follow. Just one thing, remind to follow all the dependencies that are declared to the same version. Otherwise, we might end up in strange errors. Anyway, the only thing that I found slightly different from my project was the Kotlin serialization library. They were using a beta version, I was using the stable version because Credo 6.7 needed that, but that worked out fine. So in case you don't use the same dependencies, prepare to dig into errors. Kotlin Multiplatform is still not totally stable, so it's totally fine if we get some errors. We'll deal with them. So, how can we use the coroutines on iOS? Well, that's actually easier than I expected, but not this easy. So, I heard that Swift had extensions, and I was sure that I could use my coroutines in some ways. Well, definitely not in the same way that I would use them in Kotlin. Definitely, we cannot use the extension functions in this specific way, but there are other ways. So let's see right now. So the first thing that we want to do is extend the content view. Again, we will create something that is very similar to what we create on Android for the loading complete error. In this case, it's in enum. On Kotlin, we use a sealed class, but that's really the same idea. So let's see a bit better how this will work. So, of course, we injected our dependencies, and this is how we're going to use the coroutines. So first, we create a function, normal function, non-suspending function, because we don't have the suspending keyword here. But what we will do is get in our repository the same that we used on Android, and we invoke the getLights method. This coroutine will take in a completion handler, more or less like we would do on Java. This completion handler is a lambda that takes in two parameters, which are the lights and the error. In case the lights are fine, well, we're gonna just set them to the result part of the enum. Otherwise, we're just gonna send down the error, exactly like we did on Android. The only real difference here is that, well, we're not using a suspending method and a scope to launch the coroutine, but we will use it with a callback. Less comfy, but it's doable, and it's definitely easy. Now, we need a way to create our views. And well, since the view model we create on iOS is an observable type of data, what we need to do is simply use a switch statement so that based on the specific type of the lights, we can create a different view. So in case it's loading, we can create text saying loading. Otherwise, we create a new lights view with Swift UI and pass in the lights. And if there is an error, well, we just set the error state with a possible reload. So how would that look on both the platforms? Well, this is the end result. Of course, they differ slightly, but not that much. And creating the same UI on both Compose and Swift UI is definitely simpler than any other approach that I could think of. So I guess we are at the end of the talk. We have a few minutes for questions.